Hi everyone, this is Bilal Khan and you are watching Simplified Coding. This is the application that we created so far. Now in this video we will add one more screen or fragment to this application. And actually we don't have any user's screen for this application. So first we will change the navigation options. So come to your nav_menu.xml that is inside your menu folder, and first we will change this users to quotes. So when the user will come on this screen, user will see a list of quotations. Now we have a little problem, and that is when we are clicking on this home or users, nothing is happening. This is because the ID that we given in our menu items is not matching with the ID that we given in our navigation graph. So the ID for this profile fragment is profile fragment here. So this ID should match with the ID that we given here. So let's change the ID because for home we are displaying the profile fragment. And the same way we will create quotes fragment for this quotes menu. And to create a fragment, we will go inside our UI package, and inside home package we will create one more package, and I will name it quotes. Inside this package again we will create a fragment with view model, and I will name this fragment as quotes fragment, and it will create quotes fragment, the layout file and the quotes view model. Click on finish and it will create all the three files. Now to display the quotes in this fragment that we just created, we will use this API. You can see the endpoint is quotes and it is giving us a list of quotes. And to parse this response, again we need to create a Kotlin class. And you can see we have two things here. The first thing is the response itself, and the next thing is quotes. So we have an array of quotes, and this array contains a number of or a list of quotes. So to store quotes, we need to create a class for quotes, and we also need to create a class for this response. So come back to your project, and first we will create the quote class inside our entities package. Now this quote object that we will parse in our Kotlin class, Kotlin data class, is an entity. This is because we want to use the local first approach, or we want to maintain a database cache locally, so that in case of no network connection, user is still able to use our application. So that is why we will save all the quotes into our local database, and we will fetch the quotes from the local database first. And if the local database is very old or outdated, we will update the quotes from the backend API. So this is what we need to do. So let's create an entity, and I will name it quote, and it is a data class, so we don't need body. So we have the data class quote, and we have a number of properties inside this quote class. Now this class is an entity, and that is why we need to annotate it with the entity annotation. And we will make the ID as primary key, and we will make the auto generate to false. And I guess everything else is fine. Now we will create a response in our network responses package to parse this response. So create one more class here, and I will name it quotes response. And again it is a data class quotes response, and inside this data class we have two properties. The first one is successful, which is boolean, and the next one is quotes of type list of quotes. That's it. You can see we have only two properties here, is successful and an array of quotes. So we have the class quotes response. Now we need to define DAO for our quote entity. So inside the DB package, I will create one more Kotlin file class and I will name it code DAO. And we need to create an interface code DAO, and because this is a DAO, we need to annotate it with DAO. Inside this code DAO interface, we will create two functions. The first function is to save all the codes inside our local database. So we need to annotate this function with insert, and then we will create suspend fun save all codes. And to this function we will pass a list of codes. That's it, and it will save all the codes to the local database. We also need one more function to fetch all the codes back, and we need to annotate this function with the query annotation, and here we need to run the query, which is select asterisk from code. That's it, and it is a fun get codes, and the return type of this function is a live data of type list of type code. That's it. And actually we do not need to make this function suspend. I will tell you why. So we have the code DAO. Now finally we need to create a function inside our app database to get the code DAO. So again we will create abstract fun get code DAO, and it will give us a code DAO. And here to our database annotation we need to define one more entity now, and this entity is our code class. So this is done. Now we need to define an API call inside our my API interface, and it is a get call. So we have get, the endpoint as codes as I shown you in the API, and this is a suspend fun, and we can give get codes to the name of the function, and it will return us response of type codes response. That's it, and this function is not taking any parameter because it is a simple get request that is giving us all the codes. That's it. Now as our architecture pattern suggests, we cannot call this get codes from our fragment, but our repository will communicate with this API, and our view model that we created, codes view model, will communicate with the repository. And to handle all the codes, I will create a separate repository, because right now we have one repository which is user repository, and this repository is responsible for handling the user related operations. That means user login, sign up, save user and get user. And I don't want to put the codes operation inside this repository, so I will create a separate repository to handle the codes related things. So inside the repositories package we will create one more class. So again it is Kotlin file class, and we will name this class as codes repository, and this is a class code repository, and to this class we will pass the API and the database. So we will pass private val API of type my API, and then private val DB of type app database. That's it. Now here we will create a private val codes, and the type of this codes is mutable live data, and the type of the mutable live data is list of type code. That's it. We need to import the code, alt enter and import. Now we will create an init block, and inside the init block I will observe this codes. So we can write codes.observe forever because we are not inside an activity or fragment class, so we do not need to worry about the life cycle changes. So we have codes observe forever, and whenever there is a change in list codes we will push all the changes to the database. So to save this list of quote inside our local database, I will call a function here, and it is save quotes and it. So let's create this function save quotes. So we have private fun save quotes, and it will take quotes, which is a list of quote. That's it. Now inside this function we need to save the quotes, and to save the quotes we can use this function that we created inside our code DAO. So we will call this function, but we cannot call it in our main thread. So to call this function in a different thread, we will use coroutines. And I guess one thing I forget here, which is I need to define on conflict and on conflict strategy dot replace. This means if there are two quotes with the same ID, it will store only one, or it will override the existing code. So we have the function save all quotes, and we need to call it in a separate thread. And to do this, inside the util package we have coroutines object. I will create one more function here. Till now we are working with dispatches.main. But for this operation, saving all the quotes in our local database, I will create a function io, and we will work with dispatches.io. So this is fine. Now come back to quotes repository, and inside the save quotes function I will call coroutines.io, and I will get the DAO from this DB instance. So we will write db.getQuoteDAO, and we will call save all quotes function, and we will pass the quotes that we have here. Now whenever there is a change in our quotes live data, we will save it to the local database. But we also need to fetch it from the backend API, because when the app is launched or for the first time, there is no quotes in our local database. We need to fetch it from the server. So to fetch the quotes from the backend API, I will create one more function, and it is again private, and it is a suspend fun, and we will name it fetch quotes. Now inside this function, first we will check if is fetch needed. So if we have a copy of all the quotes in our local database, we do not need to fetch it from the server. So we also need one more function that will tell us whether the fetch is needed or not. So just for now, I will create a simple function which is private fun is fetch needed, and it will return us a boolean that whether or not fetch is needed. Right now it will just return true, that means fetch is always needed. But later we will change it, and we will fetch only if it is needed. So inside this if block, we will make the API request. And because we need to make an API request, we need to inherit the safe API request here in our quotes repository class. So here we will write safe API request, and then we can use the function API request that we created inside this safe API request. So we will write val response equals to API request, and inside this API request we will perform the request using this API instance. So we will write here API dot get quotes, and we have the response. Now we will put all the quotes to our live data quotes from this response. So we will write quotes dot post value, and we will get the value from response dot quotes. That's it. Now what will happen is this function is called and the quotes are fetched, and we are adding the quotes that is fetched, the fresh quotes that is fetched from the backend API to this quotes live data. and whenever there is a change on the code's live data, we are saving it to our local database, because this observe forever has a callback. So whenever there is a change, we will save the changed or the fresh code list to our local database, and the old data is deleted or overwritten. So this is how it is working. Now we need one more function to call from the view model, and this function will give all the codes to the view model from the local database. So we will create suspend fun get codes, and this function will give us a live data of type list of type code. And inside this function we will call this fetch codes. So we will call fetch codes, and if the fetch is needed, it will fetch the codes from the API and it will push it to our codes live data, and then the codes live data will save all the codes to our local database. And then inside this function we will get all the codes from the local database to return. And to do this we need to write here return, and this time we will use with context, because we need a coroutine scope, and this time again we will use dispatchers.io. And inside this with context block we will call fetch codes to fetch the codes from API, and then we will call db, which is our db instance, dot get code dow and get codes, and this will return all the codes from the local database. Now we can use this codes repository inside our codes view model. So let's do it. But before using this codes repository, we need to instantiate the codes repository inside our MVVM application, because we are using dependency injection, and this is our object provider. So whenever we need the codes repository, we will ask it from this codin. So here after the user repository we will create codes repository like this, and it also needs API and app database that we have already here. Now come back to codes view model, and here we will create a val codes, and we will get the codes from codes repository. And because we need the repository to get the codes inside this view model, we will pass the codes repository to the constructor of the view model. So we will write here repository of type codes repository, and we will get the codes from repository dot get codes. But the problem is the get codes function is a suspending function, and we cannot call it directly. And another problem is we do not want to initialize the codes whenever the codes view model is instantiated or created. We only want to get the codes when it is needed. And to do this thing, that initialize only when it is needed, we have lazy in Kotlin. So what we can do is we can write val codes by lazy, and inside the lazy block we can put repository dot get codes. Now it will be called only when the codes is needed, and if it is already called, it will give you the codes. If it is not already called, it will call the repository dot get codes and it will give you the codes. But the first problem is already there. We cannot call a suspending function directly. So what we can do here? So we will create our custom lazy block that will use the coroutine scope to make the call. So inside the util package, we will create one more Kotlin file class, and we will name it delegates. And inside this file, we will create fun of a generic type, which is t, and we will name it lazy deferred. And it will take a block of a suspending function that should be executed inside a coroutine scope. And the return type of this function is again a generic type which is tree, and this function will return us a lazy of type deferred of type t. Now deferred is basically a job with a result, and inside this function we will return lazy. So we will use the Kotlin lazy, and we will return global scope dot async, and inside the async we will invoke this block. So we will write block dot invoke. And one more thing we need is we need to pass this inside this invoke function. And to our global scope async we will also define start as coroutine start dot lazy. So we want everything to be lazy. So we have the function lazy deferred that we can use inside our quotes view model. So here we can write lazy deferred. So lazy deferred like this, and the error is gone. Bingo. Now we can call this quotes from our quotes fragment. But this quotes view model is taking repository as an argument. And that is why again we need a quotes view model factory. So again I will copy this profile view model factory, and I will write quotes view model factory as the name. That's it. Now instead of this profile view model we will return quotes view model, and this time the repository type is quotes repository, and everything is fine now. Now we also need to define this quotes view model factory inside this MVVM application to use the dependency injection. So we will write here bind from provider, and we will bind quotes view model factory, and it will take the quotes repository that we already initialized here. So we are good to go. Now come back to quotes fragment, and here we do not need this companion object, and everything else is fine. So what I will do is I will again do the same thing that we did in our profile fragment. So we need codin aware, and we need this override val codin by codin. So I will copy this line from here and I will paste it inside my quotes fragment. But first we need to implement the codin aware interface, and then I will paste the line. That's it. So I have the codin. Now from the codin we will get the quotes view model factory. So we will write private val factory, and it is of type quotes view model factory, and we will get it by instance. That's it. Now we will use this factory to create our view model. You can see. And now from the view model we can call the quotes. And because the type of the quotes is deferred of type live data of type list of type quote, so we need to call await to get the live data from this quotes. And again we need to call the await from a coroutine scope or another suspend function. But this time we cannot use a suspending function because we cannot make this override fun on activity created a suspending function. So what we will do is we will write coroutines, the object that we created inside our util package, and then we will call the main function from the coroutines, and we will put this thing inside the coroutines.main like this. Now we have a live data quotes that contains list of quotes, and we can observe this quotes. So we will write quotes.observe, and for the first parameter we will pass this, that is the owner, and for the next parameter we will pass the observer. And just for now we will display the size of the list in a toast. So we will write here context toast it dot size dot toString. That's it. Now let's try running the application to see if it is working or not. But one more important thing we forget is we need to add our codes fragment in our navigation graph. So go to res, navigation and nav graph, and here add your codes fragment. And make sure you change the ID to codes fragment, and this ID should match with the ID that you given or that we given inside our menu file. So it is codes fragment, and here also it is codes fragment, and we will change the label to codes. And now we can run the application. So play it. And you can see the application is crashing. The reason is we changed the database and we did not create the migrations. And the very simple solution to this problem is, because right now we do not want to bother about creating database migrations, so what we will do is we will uninstall the current application. So uninstall the current application and install it again. Let's try login in. So we are inside the profile. You can see the clicks are working. Let's go to codes. And you can see we are getting a toast that is saying 2. And 2 is the size of our codes array. So it is working absolutely fine. And maybe this video is very long and a little complicated, but try to understand it. You can get my source code from the link that is given in the description of this video. And in case you have any problem, feel free to ask. So thanks for watching everyone. This is Bilal Khan now signing off.